approximately equivalent to the engine of the vehicle. Now, this engine of the vehicle has got three parameters, important parameters, which determines the size of the motor. There are three parameters. One is the torque, one is the speed of the vehicle you desire, and then the power of the motor. These three parameters are essential. Torque is known once you are replacing the engine of the vehicle. You know the torque of the engine. You calculate the motor power by using this torque, and the speed. The speed you determine, like in Mufassir in towns, urban city drive, you hardly need a 30-40 kilometer speed. That will determine the RPM of the motor. With these two parameters, you can arrive at the power of the motor. And when I say there is another factor which is important is the voltage. Many companies abroad, originally I saw that during my college days and studies abroad, I found a development of a bus on a 16-ton chassis using 220 volt lead acid batteries and using a 70 kilowatt motor with only 1 hour rating. Unfortunately, we are using a higher voltage in India and higher power motor with our buses. Same thing goes with our cars. Now, why do we need a bus with a 120 or 100 kilometer speed? Why do we need a car with 150 kilometer or 140 kilometer speed? We are a big buyer, big user. We can develop our own system. We can advise the foreign supplier to design according to our need, not according to what they use in their countries, like in America or Europe, where the roads are wide and there is no encroachment on road, no overcrowding. In India, our cities are overcrowded. Our roads are encroached upon many times. So you have to maintain the same product according to the need of the situation, not according to what others say. This is a very important factor about the technology and need-based technology. For buses, we can use, because the passenger weight is hardly, for a 50 seater capacity, hardly weighs about 3 tons. With this, you can use lead acid batteries. They were used abroad for years, for ages. The buses which were being operated by Delhi Energy Development Agency were using lead acid batteries for more than 15 years. So instead of depending upon the import of lithium-ion batteries, takes time, why not go and use lead acid batteries, which has been shown by the Delhi government as well as by the Delhi government engineers and our IIT engineers. Our Professor Aroke Semi and Professor Sood, they did a remarkable job. They worked like genuine engineers. Besides duties in guiding the students, teaching them in classes, they worked like an engineer. This is the job. After all, our professors are basically engineers. It's only after engineering education and training they come to guide others. It's a multi-dimensional approach of our institutions. Now I come to the drivetrain technology in detail. The major constituents, as I said, induction is the motor, brushless motor. You see, DC motors, use commutator and there is frequent maintenance problem. Although it's not a big issue for about 70, 80 years, these motors have been used. Now electronics has developed, so brushless motors can be used. This is the situation. It's only question of removing the engine and putting the. This has already been tried by a young engineer who is making cranes. He replaced the engine by a induction motor and demonstrated it to the competent authorities at the Delhi government. It was highly acclaimed. Now we come to the issue of electronic controllers. There are various companies abroad in UK and America. They have acquired the industry in UK. They are producing these equipment in India itself with indigenous material, and once semiconductors are indigenously manufactured, they will be substituted, without any difficulty. So with this electric drive train consisting of motor and controllers, if we use indigenous material, we can do mass production of such drives and convert millions of our vehicles easily. As our Prime Minister already said, budget is provided. It's now up to the institution and the young students to come forward. Some institutions have already done. IIT Jammu has converted car into e-car. Similarly, young student at Army Institute of Technology, Pune has shown. I'm sure you will, their video will be demonstrated on the screen. And a bus, Tata bus chassis had been converted at IIT, that is also available on the video. So now this is the situation. Now the problem, sometime the people raise a question that how to increase the range with batteries. As what Prime Minister has already said, there are two types of hybrid propulsion as well as hybrid power. In a hybrid propulsion, they say the normal so far was being adopted by overseas companies. In hybrid propulsions, sometimes what happens that under Indian condition, the battery power gets lost within the city itself because of size, the capacity is low. Then virtually the vehicle is on the oil, diesel or petrol. What has been suggested and developed abroad is put a small trolley attached to the vehicle. Or like IIT did a wonderful job, put a small DG set, a local DG set about 5 kilowatt or approximately. So what you do in a city drive, you consume a diesel of about 2 to 3 kilometer per liter. So in a 200 kilometer range, you consume about 70 liters. If suppose you attach a DG set, a small DG set, you may save 70 to 80% by using a small constant RPM DG set. It's the technology which is important, it's the application. Because there should be no excuse that charging stations are not available en route. Right from here, you can go to Hardwar, you can go to any distance by such combination of the propulsion. The bus or vehicle is purely electric, battery operated, supplemented by a normally this application normally to an average user hardly may be required in a month or casual things. The Delhi Energy Development Agency's engineers had already tried this system by attaching a trolley on their vehicle when they were operating it in the city. So this is the situation as far as the battery source of power is there. Now, another good point which our transport minister has done, he has widened the roads, converted many roads into several lanes, including dedicated lanes on each side of the road. On these roads, you can draw power from the overhead line. You see, the another advantage of electric vehicle is that your source of power is at least 70 to 80% indigenous. What is your source of power, which is common to the grid? Hydroelectric, coal produced, solar, wind energy, nuclear energy. You see, another advantage, and the faster we work, the faster we reduce our dependence upon imported oil. So we are in a very win-win position. It's a big market, and we can design the system. We have got technical expertise to design the system according to what we need, not according to what foreign interest produce and give it to us. This is the major problem with us. During Chinese Pakistan, I was called upon by the security forces on the border. Mr. Agarwal, we are in a soup. We don't have any communication equipment. Can you produce it, design it? I said, yes. But give me the exact requirement so that we can produce it. When they gave their exact requirement, not the requirement which was being produced abroad, the cost went down 50%. Designing time went down from a few
Excuse
years.
me, sir, may I interrupt for a moment?
So this is the advantage of producing, designing, and developing based on what you need, not what others say. This is a very ticklish question because there are very vested interests.
Excuse me, sir, may I
They will
interrupt for a
press.
moment?
And what happened? It is happening all over the world, particularly they are trying to push India into
Excuse me, sir. May I interrupt for a moment?
situation where we continue to depend upon them.
Hello, sir. Are you listening?
So, whenever we want to develop,
Excuse me, sir. Hello.
with a practice to develop something what you need, and then go step by step. Go step by step. Then you can achieve the target. Instead of jumping on the top ladder, you start with this. And our Honorable Prime Minister clearly said, start with converting millions of vehicles economically as a cost-effective short destination solution in a rapid system. Now, this is all I have to say, that in a conversion thing, there is no situation, everything is available, technology is only brushed up by the technical institutes are there. It's only question of MSME industries to come forward and take up this lead. Thank you so much. Any question?
Thank you, sir, for that profoundly detailed and inspiring session. Your valuable guidance on indigenous electric vehicle technologies,
Any question, please?
especially the development of motor controllers and EV drives. Your perspective on reducing dependency on imported lithium batteries and exploring efficient lead acid battery solutions developed by IIT engineers gave us a new direction to think about sustainable innovation in India. We sincerely appreciate your time. Thank you, sir. Moving forward, our next expert comes from the heart of the automotive industry. It gives me immense pleasure to introduce Mr. Prabhat Kumar Jha, ex-Deputy General Manager, Production Division, Maruti Suzuki India Limited. Sir is a specialist in automotive manufacturing, production, management, and quality assurance. His perspective on the transition to electric vehicles will be valuable. Please welcome Mr. Prabhat Kumar Jha.
Thank you very much. My slides are visible to everybody.
Yes, sir, they are visible.
Okay. So basically, the lithium ion battery story started back in Alessandro Volta invented electric battery in 1800. And after that, in 2019, these three gentlemen, John B. Goodenough, M. Stanley Whittingham, and Akira Yoshino. And you will be happy to know that I have a chance to interact with Akira Yoshino in Japan. So these three gentlemen, they have invented this lithium ion rechargeable battery, lithium ion phosphate battery, lithium ion manganese oxide battery, and all these three gentlemen, one Mr. John B. Goodenough is from Yale University, University of Chicago, and the M. Stanley Whittingham is a British American. He working. He was working in U.S. Department of Energy, and still he may be there. And his degree is from Oxford. And from mobile phone to electric vehicle, everywhere this lithium ion battery is used. The Akira Yoshino is connected with the Asahi Kansai Corporation and professor of Meiji University. Actually, everybody know about FAME 1, FAME 2? Okay, no problem. So I want to give a brief thing that going into the detail, there is a faster adoption manufacturing of electric vehicles in India. That is called FAME. Faster adoption manufacturing of electric vehicle in India. This is FAME. So I am audible and these slides are visible. Please confirm it so that I can continue. Is it audible and visible?
Yes, sir, it is visible.
Okay. And audible, beta? It is audible?
Yes, sir, yes, sir.
Okay. So power energy density plot for electrochemical energy storage devices. I will send these slides to you, everybody. I am giving descriptions, and at the end of this, I will give it to everybody, whosoever is here in the hall. So you will give me the mail. I will send it to you people. Now, the basic energy is the capacity to do work. And the capacitors, you see the energy density, watt hour per kg, although our energy is kilowatt hour in our household use, and power density in watt kg. If you will go to this, there is a four things there: electrochemical capacitors, batteries, and fuel cells. These are the details. You can go through it and see. So when you need high power, power, high energy batteries, new material and new technology is required to meet the demand for the high power and high energy batteries. Now you come these lithium ion batteries in these different shapes. This is you go these first, second, third, fourth, fifth, and sixth, so on. So anode, separator, cathode, everything is there, and the different shapes are available in the market. Then you go to the general battery configuration. This is in three phase. There is a cells, there is models, there is a pack. So type of cell based on chemistry, that is combination of nickel, manganese, and cobalt. And the second is this LFP, phosphate as a cathode material. When you use this is LFP. And then come types of cell based on geometry, that is it may be prismatic, it may be cylindrical, it may be in a pouch. And models are different. This is a series, parallel, and combination of series and parallel. And the pack is category of battery packs based on ISO 64693, that is class A and B batteries, low voltage class 1, high voltage class 2, and high voltage class 3. So these are the three packs available. And then you come to the battery model assembly. So you see these structures. I will send it to you. And then lithium ion battery pack assemblies, you will come to this now. What inside the battery pack? This is cell or models, that is cells, casing, and V-sense, T-sense, cell fusing, and all the electrical engineering students can understand this, and they are more expert in this. They can understand in a better way. So bus bars, terminals, connectors, and thermal management system, so that cold plate, cooling manifold, coolant port, etc. And then BMS, that is battery management system, and high voltage, low voltage connectors, MSD, bottom and top enclosures with sealants. This because I got this during my training in Maruti, so I have given all these things. If it looks very heavy, then I can change it to a different way. So please interrupt me if you feel it is little bit heavy. So the functionality of batteries is new challenges for batteries there, that power control and energy management is there, communication and AI in EVs, and then modes and connectors for the charging, eco charging, AI and EVs, improvement in the charging processes. These things, the functionality of the batteries you can see, and genetic battery management system, that is user interface and electrical control. You see the battery monitoring is current, voltage, temperature. You people may be knowing of all these things. So current, voltage, and temperature is the data acquisition, and then there is a safety protection system is there. So electrical control, user interface, and the battery management has these two important parts. So there should be communication and the thermal management in this. Now, design to value and design to cost. So you can see the objectives: ensuring crash safety, vibration isolation, thermal run away prevention, cooling efficiency, available cell types, and the design to cost. You can go through this and you can see higher speed manufacturing, low unit cost, sustainability, weight and size. The methods are reducing number of parts, optimized material selection, choice of joining technology, quality assurance system, and increasing automation. Now, going into the detail, you will see that the conversion from ICE to electric vehicle, so mechanical system, engine, transmission, gas tank, exhaust, and the different multiple speed of motor and clutch has to be removed. Then you will shift to electric motor, batteries, power controller, wires, additional cooling system, inverter, and battery charging. So these are the things, that 7 things that electric vehicle contains. That is electric motor, batteries, power controller, wires, additional cooling system, inverter, and battery charger. Now, if you will go to the EV and ICE, you see that here is energy conversion electric motor at the top, and right side energy transfer fixed ratio gearbox, and then power electronics AC DC inverter, you can say, and then energy storage lithium ion batteries is at the back, and sometimes maybe in the front, depends on the system. So energy input plug in the port and ECDC converter is there. And ICE, you know, everybody knows, so need not to go through this. These are the things that you have to go through. And then key parts of subsystems that we manufacture when we manufacture these things: the body design, the body structure, the frame, the bumpers, suspension. And you see that there is a 2 symbols here: moderated interactions and very significant interaction. The sign is given there. So energy source is batteries, battery charger, and then electronic propulsions, that is electric controller, power converter, electric motor, transmission, wheels, brakes. The auxiliaries are brakes, the steering, auxiliary supply, temperature control, and energy management. So when you go for battery electric vehicle configuration, there is a battery, and there is an inverter, and then electric machine is there. So single speed gear, and then a differential, and the driving wheel pair is there. Power is transmitted in this way. So batteries AC DC power is converted to AC by the inverter to run the motor. Whenever you want to run the motor, you will have to convert this DC power to AC power. Then only you can run the system. Then you see the modern vehicle electrification is IC. There are different stages in the micro hybrid, mild hybrid, hybrid electric vehicle, and the plug-in hybrid electric vehicle, and range extended electric vehicle. So if you get bored, then you tell me. I will change the modus operandi. And the first thing is that I see conventional gasoline diesel engine, then a start-stop system is in micro hybrid, and then electric motor. And gradually we shift from this to 0 kilometer, 50 to 80 kilometers, 150 to 500 kilometers on the basis of the size of the battery. Am I clear to you all people? Am I clear?
Yes, sir, completely.
Thank you, beta. So nice of you. So the total cost ownership analysis graph is there. Annual maintenance cost is next slide. You see the cost of service of your red is for TCO internal combustion engine vehicle is there, and the green is for battery electric vehicle. So you see that initial stage there is a higher cost of service, but later on it becomes normal. No more cost is there. And annual maintenance cost is because rotating part is reduced, so the annual maintenance cost is roughly very low, but initial cost is high. So you will have to consider this also, that initial cost is very, very high, but one time. So cost of service and maintenance is roughly half that of a petrol car. So if you consider the cost also in industry, it is better, but initially you will have to have the technology, and we will also discuss the drawbacks that the system has. And then what is the impacts of EV? You can go through and you can see this. And then you see the comparison of saving in cost per kilometer offered by the vehicle. Gasoline, if you consider the electricity, go to the last column, 75%. And the gasoline, if it is zero, then it is a 50%, 75% higher. So LPG, biodiversity, diesel oil, hybrid, blah, 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 E85. And you see the electricity, how much this vehicle is cost per kilometer saving is there. 75% saving is there with you. So it is better. Although there is some problem in the system, you will have to go through these, face the problems. And when we become regularized, it will be a better system. You will have a better service for that. Then if you want to summarize all these things, IC to BEV is dozens, if not hundreds of engine and transmission parts. For example, the average 4-cylinder has 113 moving parts. 113. Currently, automotive parts suppliers contribute 50 to 55% of value of an IC powered vehicle that might shrink to 35 to 40% of a BEV. So BEV suppliers revolve around the battery pack and power electronics, as well as motor laminations. For rotor and stator, battery packs are complex system combining battery cells assembled into fabricated modules. So the transition means engine and transmission, electric motor, high speed, single speed gearbox, fuel tank, engine, etc., etc. So BEV has new disadvantages regarding its cost and ease of charging points. It is telling that you please remember one thing, that battery discharges below 10 volt, battery management system fails, may block recharging for safety reasons. So if you charge the battery electric vehicles, lithium ion battery, and you go less than 10 voltage, then you will not be able to charge it again. So be allowed for this. Second thing, the cost is initially very high. There is a temperature sensitivity. So you should keep these batteries when you are not running between 0 to 25 degrees C. Otherwise, I have seen there is a problem. So please don't do that. There is safety risks like fire and explosion. And one thing is very, very important, that lithium battery, whenever you charge lithium battery, gentlemen, please charge on the principles of 80-20. Means for general use, you charge it 80%. When you will go for the local around your city or somewhere, don't charge more than 80%. So your efficiency will be the maximum. Then what you do, that 20%, never ever go below 20% charging. And then whenever you go for the long drive, you charge it 100%. So never charge less than 20%. Only for long drive 100%, for the local or daily use only 80%. And never ever forget to store these batteries at 0 to 25 degree C. ओके बच्चों, मैं ठीक से आपको कम्युनिकेट कर पा रहा हूं?
Yes, sir.
Beta, I am audible?
Yes, sir.
Okay. Thank you. So nice of you. As per the analysis done by SNE Research or maybe the other organizations, for a battery demand of 2002 gigawatt hour in the first half of 2022, and registered a growth of 76% in demand as compared to the first half of 2021. Now, global EV battery demand, this is you can see the graph. battery chemistry split, and you can go through it when I will send the slide to you people. Then you see that electric vehicle market structure in India. This is electric vehicle market structure in India is of normally 4 types, if we'll go for that. It is electric vehicle, the two-wheeler, then it is three-wheeler, then it is four-wheeler, then agricultural tractors, etc., etc. So the lowest speed means 0 to 25 kilometer is this E2W, electric vehicles 2W, two-wheeler, 25 to 70 kilometer per hour motor size, 4 kilowatt, and L2 above 70 kilometer per hour motor size, maybe 4 kilowatt. So when you will go for three-wheeler drive, it is up to 25 kilometer per hour motor size, that is less than 2 kilowatt. Passenger and goods carrier both can be comes under this vehicle. So e-rickshaw and e-cart can be of this type. And then go for L5. This is a speed above 25 kilometer per hour. Size is greater than 2 kilowatt. And then L5M passenger and L5N goods carrier. We will discuss it if we'll go for these things in detail. It will take more time. So, and now come for electric vehicle four-wheeler. That is not more than 8 seats in addition to the driver. That is less than equal to 4-meter sedan. And then M2, then M3 buses, and then L7M quadric cycles length that you will feel and you see on the roads of the our country. And you will go for the goods, that is N1, N2, N3, and L7N. Now you will come to the agriculture tractors, that is A1, minimum track width is 1150 mm, unladen mass is greater than 600 kg, ground clearance is 1000 mm, less than 1000 mm. A2 is minimum track width 1150 mm, unladen mass is greater than 600 kg, ground clearance is less than 600 mm. And then A3 unladen mass is less than 600 kg, and A4, etc., etc. The source I have written below. This source is for my data. So I remember one of my teacher in my college when I was in engineering college. He used to tell me that if you speak anything without data, it is your opinion, and opinion has no value. So I try to give the data for the things that is here. And I also tell you, all my students should have data with you. That is your backup. That makes you more stronger. So the battery parameters, lithium-ion battery cell types, and EV energy systems are given here. And you are seeing these. Beta, up to 11:20, my time is there, na? 11:20?
Yes,
5
sir.
minutes
Yes,
before I will have to stop. Okay,
Yes, sir.
11:15, you can say.
yes, 11:50.
Okay, beta. Okay, beta. Okay, beta. I am trying to close it by the time. So, energy density, power density, and all these things you can go through. You will cylindrical cells, pouch cells, prismatic cells, which we have discussed already. And EV energy system is cell, module, pack, and vehicles. You can go through these slides also. And then global advancements in battery, that is technology for EVs, 2005 to 2025. The effect of increasing the energy density on weight and volume reduction, a battery of same size kilowatt hour will weigh 10 times less if the energy density increases from 100 watt hour per kg to 1000 watt hour per kg. So please note it down. And I will suggest you people, all the people who are innovative, doing some work behind this, you will go through a book, Rework. It is a wonderful book, Rework. And I will say the David Henson's book is there. That is how you can become an entrepreneur. So these things you can, if you want to develop in your own way, you please go through the book. It will help you a lot. The size of the circle marker indicates ERC legend on the top left. You will see that. So all values refer to system level energy densities, not cell level, not cell level. System level includes weight of all other BOP components. The plus sign levels are cell level energy density. That is, you always see in the batteries, the plus and minus. These are shown for lithium ion because they are used as stand-alone cells in some applications. So Indian electric two-wheeler market up to 2022. So market share analysis, you can go through the Okinawa, Hero Electric, Ola Electric, Ampere Vehicles, Ether Energy, TVs, Bajaj Auto, Revolt Motors, and other things. So the data is given there. You can go through these things. And now, India low speed auto rickshaw market up to 2022. That is this 2,15,573. You can go these data. The 5 lakhs ICAT approved models on road, 11 lakhs on road, including non-registered ones, and share of passenger versus commercial e-rickshaw in 2021 passenger. That is 91%. Commercial e-cards are 9%. So now Indian electric four-wheeler market up to 2022. So the electric car market in India is witnessing continuous increase in traction from the personal segment customers since the launch of high performance car in the market in 2020. As per the data available from Bahan portal, you can go to the Bahan portal, can find out these data. Industry has already sold 25,949 units in first 9 months of 2022, and further anticipating to cross 50,000 sales figure in these. So this is old data when I was doing a workshop for Maruti with one of my competent electrical engineer, my colleague DZM. The data is a little bit old, but later on I will show you better data also. So latest data. Indian electric four-wheeler fleet car segment outlook. You see here the several companies have already launched a fleet of electric cars in country. A close examination of four-wheel fleet adoption shows that market has opened at both business to business and business to customer level. So Lithium Urban is operating the largest fleet. Everybody, I think, know B2B, B2C, and all these things like that. So car in B2B segments, followed by BLU Smart in 685 vehicles. So majority of the players are operating electric cars daily over 225 kilometers to 300 kilometers, making TCO attractive for the electric cars. Further, continuous increase in fuel prices have helped improve the business case for e-fleet operators, as the profit margin for internal combustion engine fleet operators have narrowed down significantly. So people are moving towards this also. And now you see these previously, these were the cars up to 2022. Now you come to the electric bus market in India. That is, you see that Kolkata 2000. This is January 2022 data. So the 2000 is in Calcutta, but in Surat it is 175, and the various Telangana, Delhi, you can see all the data are here, and the source is already written here below. So the central EV policy, India, you can see that National Electric Mobility Mission Plan. And I have already tell you FAME. Anybody, or everybody should know FAME. So faster adoption, manufacturing of electric vehicles in India is FAME. The FAME 1, FAME 2, FAME 3, we have crossed all. So National Electric Mobility Mission Plan, this Prime Minister, you people have listened, so need not to explain that. So National Electric Mobility Mission Plan 2020, and like MEP 2020, National Education Policy 2020, this is also National Electric Mobility Mission Plan has been given in 2020. Then 2015, this given in 2013. Then FAME 1 is in 2015. And then we come to the 2018 classification on EV charging as a service by MOP. Excuse me. Hello. इसको फोन को रखो. Okay, sorry. So classification on EV charging as a service by MOP guidelines and standards for setting up of public charging. Card then also not required to talk. So charging infrastructure by MOP. So now you come to the 2019, 20, 21, and 22. So 2019 phased manufacturing plan for EVs, its components. FAME 2 scheme is there. FAME 2, again I am telling, faster adoption, manufacturing of electric vehicles in India. FAME 2. In FAME 2, they moved from personal vehicle to the social, means if you collect, get social vehicles, you will get you will get subsidy for that. So GST reduction on EVs chargers to 5% draft notification by MORTH to waive off registration charges by EVs. Amendments in model building bylaws by memorandum of understanding. So then come to the 2020, and that is the revised PMP program, the MOP amendment, battery swapping considered under public charging stations. Then you will go to 2021, accordingly the FAME 2 scheme, extension of FAME 2 scheme by another 2 years to 31st March 2024, and then gradually revised in 2022. You see the revised standards and guidelines by MOP for setting up EV charging stations. Announcement on battery swapping policy by FM. Announcement on battery swapping policy by FN in budget 22-23, and amendments announced by these organizations. And then phased manufacturing program for EVs, you see there is 18 headings: the body panel, the instrument panel, the vehicle control unit, the DC converter, the electronic throttle, and all these things like that. So you can go through this also. And Indian gigafactories. Gigafactories means the major factories, bigger factories. That is gigabyte. You may know in the computer, like the gigafactories where you. So you can go through this. You see in the map, the source is CES Research Analysis. You can go through CES Research Analysis. You will find all these data. And the lithium ion battery pack makers in India, that is 30 plus companies, have already started manufacturing lithium ion battery packs for e-mobility and stationary applications in the country. However, the number of companies making complete packs starting from cell to end of pack needs to be verified. So these are making batteries, but starting from cell to end of pack, you should have to verify of your own. Okay. And then EV motor offerings across segments in India, that is Bosch, Lucas TVS, Anti-Green Propulsion Labs, Tata Auto Components Manufacturer, Sales Propulsion Private Limited, and blah, blah, blah. So you will see that E2W, E3W, E4W, SEV, LCV, HCV, and all these things. The data is industry input, secondary research. You can find it out in and if you need more, I will give you the sources. Then EV motor offering across segments in India, different segments, the motor type, the motor offering across vehicle segments, you can find out, and the details are there. The source is industry inputs and the researches. So you can also get these data. Now, basics of EV charging is what? The AC charging and the DC charging. So somewhere you will feel that as I have seen in Korea and other places, the DC charging is direct DC charging is there also. If you see the right side is DC charging, you can do it from that, and left side there is AC charging. So it convert the AC onboard charger, the lithium ion batteries converts it into DC. And if you somewhere there is a DC fast charging stations are also there. AC charging stations is a little bit, it will take more time. Okay. A few global EV charging connectors, you go just to the last column, that is India. That you will see that, as I know, there may be improvements in that, there may be things improved, so it may be new things may be added in this, and so these are the connectors that is available. You can verify it. And the number is AC001 IEC 60309 and GB/T CC S2 CHAD MO. You can find out all these things. Now I want to wrap it out in 7 minutes. So India EV market outlook by 230 sales penetration target. You can go through these datas. You can have all the details. Then EV and battery market outlook. You can see the BAU, and then you will see the different data is here. And now 21 lakhs EV sold in last 12 months from October 2024 to September 2025, and these include all the vehicle. Mind it that this includes all the vehicles up to September 2025. So this is latest data. If you want to go through it, you can go through it. So the fuel-wise two-wheeler sales trend September 2024 to September 25. This is the trend is still good. You can see that in March 25 it was peak, but still it has reached the 8.7%, and in September 25 it again down to 5.5, again go to 8.1%. So you can check this from the sites and all these things like that. So high speed E2W two-wheeler sales trend by OEM, you can go through. The data is available here. And then fuel-wise fold-W passenger cars sales trend. You see that there is a peak in August 25, but little bit small dip in September 25. So you can have your speculation, futuristic projection like that. If you want to develop your own unit, you work like that on the basis of that. And then OEM wise E4 wheel vehicle September 2025, you see the data, the market share, and the percentage change, the difference, and September 25 and August 25, the difference is there. You can go through the Tata Motors, Mahindra, Volvo, and so on. So these one thing I want to tell you, one more thing, that please wait for 2 minutes, because I have 5 more minutes. So I want to bore you for 5 more minutes. This is a little bit thing that when I will have to snap it out quickly to the people, I go through this, that electric vehicles, issue, innovation, and future trends. You see that an electric vehicle is a vehicle that uses one or more electric motors for propulsion instead of petrol or diesel engine. It uses a rechargeable battery to store its energy, which is supplied to the motor to drive the wheels, which is supplied to the motor to drive the wheels. So it uses a rechargeable battery to store energy, which is supplied to the motor to drive the wheels. Now, type of electric vehicles. This is battery electric vehicles, BEV, that is runs fully on electricity, uses a large rechargeable battery. Hybrid electric vehicles uses both an internal combustion engine and a small electric motor. And third is PHEV, plug-in hybrid electric vehicles, has a bigger battery than HEVs and can run short distance on pure electric mode, needs external charging, but also has a petrol diesel engine for longer trips. Now, FCEV, fuel cell electric vehicle, that is powered by hydrogen fuel cells that generate electricity on board, emits only water vapor, and refuels faster than battery vehicles. Now, you come to why the need for EVs. Why we need EVs? Because sustainability and cleaner air you can get, reducing oil dependency, lower operating cost for consumers, enabling smart future ready mobility. And then the EV stories is there. I don't want to open all these things. So you see that there 80 million scope is there. So you will have to see all these things. And India's electric vehicle sector is entering one of the fastest growth phase in its history. Is less than a decade, EV adoption has surged from a niche early market phenomenon to a nationwide movement driven by policy support. Falling battery costs and rising consumer confidence, India is now positioned to become one of the world's largest EV markets, powered by a strong demand for two-wheelers. अरे you go to the road यार, देखो वो बैटरी वाला जो जितने रिक्शा हैं दिल्ली में तो बड़ा पड़ा है, आपके यहाँ भी होगा. So this is expanding charging infrastructure and ambitious national targets that signal long-term commitment. So it is explosive growth in EV adoption, two-wheelers leading the transition, a strong policy push, and clear 2030 target. So policy framework, every 2 minutes is there, beta, so I will take 2 minutes fully. So policy frameworks driving India's EV transition, national incentive scheme is there, FAME 2 is there, manufacturing PLI means production linked incentive is there, state level policies are there, that is road tax waivers, registration, fee exemptions, etc. Charging infrastructure development is going in a fast way. Now I will talk about the case study of Maruti Suzuki India Limited, the story's entry into the EV market. The Maruti Suzuki announced its first fully electric model, the EVX, which will launch, but because data was available but it is already has come in the market, 2025, built on dedicated EV platform. It featured a 60 kilowatt hour battery and estimated 550 kilometer range. So manufacturing scale and localized, that 10,400 crore is invested in this, building EV ecosystem partnership, and R&D, hybrid technology as a transitional pathway, and these things are there. And issue challenges we have already discussed. So a simplified flywheel view of key obstacles slowing is this supply chain is difficult. You will have to consider it in a good way. So battery safety and life cycle issue we have discussed already. And then high upfront costs, range anxiety means daily use patterns are affected by fear of running and charging. So people are afraid of these things. Thank you very much for listening. Thank you. Thank you very much.
So, first of all, I would like to say that we all loved your energy and getting bored was not an option for us.
Thank you, Betty. Thank you. So nice of you.
So, before thanking Sir, I would like to mention what I initially forgot to mention in Mr. Prabhat Kumar's achievements, which is Mr. Jha has trained more than 100,000 professionals, students, and public sector personnel across India and abroad, conducting programs for Maruti Suzuki, Delhi Police, CRPF, NHPC, Power Grid, IOC, and several NITs and universities. A certified UHV trainer, mechanical energy, and PGDM graduate from IMI Delhi. He continues to inspire individuals through value-based leadership and behavior training and mentorship.
Thank you so much, sir. Prabhat Kumar Jha sir's insightful lectures covered the crucial role of lithium-ion batteries in energy storage, providing a detailed cost per kilometer comparison that highlighted the economic viability of electrical vehicles. He addresses the strategic introduction of EVs into the Indian four-wheeler market, emphasizing the positive outlook for the electric fleet car segment due to favorable ownership cost. The lecture also tackled technical and market growth aspects, discussing how advancements are overcoming range anxiety and noting the significant increase in EV options after 2022. A key focus was the growth of EV bus market, showing success stories and deployment figures from public transport undertaking in regions like Kolkata and Telangana. We sincerely thank Mr. Prabhat Kumar Jha sir for providing these comprehensive understanding of India's accelerating electric mobility future. Sir, before proceeding, some students have some questions from you.
Please.
Okay.
Hello, sir.
Yes, madam.
I'm Yusuf Khan. Sir, my question is this. In a cold weather, the lithium ion batteries decrease their performance and become partially damaged. So how it will be managed?
Beta, if the temperature is between 0 to 25, go below 0, it is a problem for you. But if up to now the batteries are developing in such a way that if it is up to 0, means in India, beta, this will not problem. This will not be problem. Have you felt problem actually on road?
No, sir. During
नहीं
charging,
तुमको होगा बेटा यूसुफ, नहीं होगा, क्योंकि हमारे यहाँ टेम्परेचर उतना नहीं गिरता, तो हमारे लिए इट इज बेटर. बट हाँ, चार्जिंग स्टेशंस की प्रॉब्लम हो सकती है. एसी चार्जिंग माने डीसी चार्जिंग यू कांट हैव एवरी पॉइंट. So AC charging converter will take longer time, but temperature, I think you can go with Yusuf. You can buy the car if you want. No problem. It will not be so.
Thank you, sir.
A very good morning, sir.
Thank you.
सर मेरा क्वेश्चन था कि हम लोग लिथियम आयन बैटरी बनाते हैं, तो उसके लिए हम लोग लिथियम, कोबाल्ट और निकेल के लिए माइनिंग करते हैं.
हाँ.
तो सर जब हम लोग माइनिंग कर रहे हैं तो हम अपनी प्रकृति के साथ सीधा सा छेड़खानी कर रहे हैं.
हाँ.
पहली चीज. दूसरी चीज ये हो गई कि सर हम लोग जो लिथियम निकालते हैं उसकी सफाई के लिए बहुत ज्यादा पानी यूज करते हैं। तो सर इन मामलों में कई जगह पे क्या हो सकता है कि मतलब पानी की कमी हो सकती है। तो सर ये कैसे हम लोग कह सकते हैं कि ये जो प्रोजेक्ट है ये इको फ्रेंडली है, और उसके बाद सर कि अगर हम लोग इसको एज ए इको फ्रेंडली ले भी लें तो सर क्या होता है कि ईवी बैटरीज जो होती हैं वो रिसाइकेबल नहीं है, हम लोग उनको रिसाइकिल नहीं कर सकते हैं आफ्टर सम टाइम, जस्ट लाइक 2 years और 4 years। सर क्या होता है कि हम
Only
लोग
10 year, 10 year. I'm
ओके
interrupting.
ओके
10
सर,
year.
ओके सर 10 years।
हाँ.
सो सर 10 साल बाद हम लोग उनका क्या करेंगे, क्योंकि अभी हमारे पास ऐसी कोई भी प्रोजेक्ट नहीं है, ऐसा कोई भी सिस्टम नहीं है जिससे हम लोग उनको ढंग से रिसाइकिल कर सके। तो सर क्या होता है कि मतलब उसमें एसिड रहेगा। ओके सर, जब हम लोग उसको डिस्ट्रॉय करेंगे, हम लोग उसको जंक डीलर को देते हैं, तो सर क्या करेगा, जो उसमें एसिड होता है उसको फैला देगा। तो सर आप जो अड़ोस पड़ोस का एनवायरमेंट है वो सर इफेक्ट होगा, क्योंकि पड़ोस में जो पेड़ पौधे होंगे सर उनमें भी एसिड जाएगा, और अगर सर कोई नदी है, नाला है, तो उसमें भी सर एसिड जाएगा।
Beta.
जी सर।
Please listen me carefully now. Your question completed?
यस सर।
First is this, that cleaning of the battery, cleaning of lithium, a number of things developed so that the less water can be used. And you go through on the net also, and there is the cleaning system has been established in USA, in South Korea. You can go through that and you can see it. Second thing, you are talking about the disposal of the battery. Of course, in India, we have the certain problems, but people are working on this, and it will be, बेटा आवश्यकता आविष्कार की जननी है, तुम इसको वेट करो और तुम ही ढूंढोगे इसको. You people will search it out because it has a lot of benefits. आप देखोगे कि पानी की जो कंजम्पशन है, वो कंजम्पशन अगर आप क्लोज्ड एटमॉस्फेयर में इसको क्लीन करो, यू कैन रिसाइकिल द वाटर, यू कैन यूज इट. सेकेंड थिंग, दैट disposal system also possible. You can do it, and the waste management is, you can say, developing in such an enormous way. We will search out the way. आप ही देखो, इन तीनों साइंटिस्ट से पहले हमें पता ही नहीं लिथियम बैटरी का था. We find out the thing that ये आज हमारे पास लिथियम आयन बैटरी है, तो ये इसके डिस्पोजल के सिस्टम को भी हम ढूंढ लेंगे. हाँ, हमारे यहाँ दिक्कत है, बट इट विल बी कंट्रोल्ड, इट विल बी रिसाइकिल्ड. ट्रस्ट मी, I am telling you. So I am requesting you, all my students, that go through rework. That is the
thank you sir.
Good book, and it will give you all the answers. Thank you.
हेलो सर, गुड मॉर्निंग.
हाँ बेटा.
सर जैसे कि हम देखते हैं कि जो इलेक्ट्रिकल व्हीकल होती है उसमें जो मेन हार्ट होता है, जैसे हार्ट ऑफ ईवी बैटरी कह सकते हैं, वो बैटरी होती है.
हाँ बेटा.
लेकिन जो एक बार जैसे बैटरी अगर डेड हो गई तो उसमें जो इनिशियल कॉस्ट होती है उसकी इलेक्ट्रिकल व्हीकल की, वो बहुत ज्यादा बढ़ जाती है. जैसे
हाँ बेटा.
अगर 80,000 की बाइक है, अगर बैटरी एक बार डेड हो गई तो उसकी जब नई बैटरी लेने जाएंगे तो 40,000 की बैटरी हो जाती है. तो उसमें सर बहुत प्रॉब्लम आती है. और दूसरी चीज सर, जैसे आईसी इंजन में जो टॉर्क जनरेट होता है एज कंपेयर टू ईवी बैटरी, वो सर बहुत कम होता है.
हाँ.
और जो ड्यूरेबिलिटी है वो कम है सर, ईवी बैटरी की जो ड्यूरेबिलिटी है वो कम है एज कंपेयर टू आईसी इंजन.
बेटा, फॉर दैट आई एम सजेस्टिंग यू, जो बैटरी 10 वोल्ट से कम, माने 20 से कम तो जाओ ही नहीं, तुम कभी मत जाओ. अगर ठीक से चार्जिंग करोगे तो मैं तुमको गारंटी के साथ कहता हूं, हालांकि मैंने 10 साल नहीं देखा, उतना समय में मारुति में था ही नहीं, लेकिन मैं तुमको एश्योर करता हूं 10 साल तक कोई प्रॉब्लम नहीं आएगी. तुम 80% से ज्यादा चार्ज मत करो अगर लॉन्ग ड्राइव पर नहीं जाना है. मैं मोटरसाइकिल की भी बात कर रहा हूं बेटा. और तुम 100% मोटरसाइकिल को चार्ज ही मत करो, क्योंकि मोटरसाइकिल से तुम लॉन्ग ड्राइव तो जाओगे नहीं. एंड ट्रस्ट मी, यू विल हैव अ बेटर सर्विस बेटा, यू विल हैव अ बेटर सर्विस. उसकी टेम्परेचर सेंसिटिव ही इतनी डेंजरस नहीं है. तुम्हारा 10 साल चलेगा बेटा, उसको मेंटेनेंस ठीक से करोगे तो 10 साल चलेगा, कोई प्रॉब्लम नहीं आएगी. तुम इसको करके देखो बेटा, ट्रस्ट मी. आपने फेस किया है प्रॉब्लम पर्सनली?
No, sir.
हाँ बेटा, देखोगे तो तुमको देखो थोड़ा प्रिकॉशन तो लेना पड़ेगा, तो तुमको गेन के लिए थोड़ा पेन तो है राजा बेटा, बट यू कैन डू इट, नथिंग टू वरी.
Once again, thank you so much, sir, for your valuable time. And we will move forward with our next chief guest, Mr.
Thank you.
KPC Singh.
Thank
Moving
you.
forward, our next expert, Mr. KP Singh, MSME, New Delhi. He is an industry leader with deep understanding of MSME growth, technology adoption, and entrepreneurship. Mr. KP Singh is a distinguished industry leader and currently serves as the president MSME New Delhi, where he plays a pivotal role in advancing the growth and competitiveness of micro, small, and medium enterprises across the region. With a deep and practical understanding of MSME development, technology adoption, policy implementation, and entrepreneurship, he has been instrumental in strengthening industry institution linkages and enabling small businesses to embrace innovation driven growth. Known for his strategic leadership, Mr. Singh actively supports capacity building initiative, skilling programs, and technology integration to empower emerging entrepreneurs. His vision focuses on creating a sustainable and future ready MSME ecosystem that contributes meaning to India's economic and industrial progress. Please give a round of applause for Mr. KP Singh.
Namaskar. First of all, it's a pleasure to be here, and I see a lot of experts in this. Commodore Saxena ji is there. He is very knowledgeable and master of this electrical vehicle technology. And our previous speaker, H.K. Agarwal ji, is 94 years old. I've had the opportunity to work in his team. Of course, we could not take it long, but whatever time spent with him was really memorable. And definitely, these people who are, previous speaker and the speakers to come, they will be highlighting more on the subject. So my topic is not exactly pertaining to the electrical vehicles, but definitely I will take you to my the space where I am expert. You can't say, but I have the experience of that. So definitely we can begin with something. I would like to tell you something about, because whatever we do in the college projects, it's not only for the sake of that we have made some project and we just take it for learning purpose, because whatever we do, it need to be validated. The idea need to be validated, and the project we do, it should be capable of monetizing, because that is what is all together. And I'll tell you something about how the business can be started. So if I can share my screen with you, and are you able to see this?
Yes, sir.
No, my screen was available.
No, sir, your screen is not visible to us.
Just a minute. Is it now?
No, sir.
Not yet. Huh? Just a minute. How about now?
Yes, sir, now it's visible.
That is visible. Okay. So I'll be taking you to this. I'll just, for a while, I'll just switch off my camera so that my internet does not have problem. Okay. So it's about MSME opportunities in India's revolution, innovation, entrepreneurship, value creation, and the agenda for
Sorry for the interruption, sir.
yeah.
Can you please minimize the screen of your mobile phone? Your PPT is in getting interrupted.
Is it okay now?
Yes, sir. It is okay now.
Okay, thank you. So we start with, and once again, good morning, everybody. It is a privilege to be here at RR Institute of Modern Technology, Lucknow. Speaking of speaking to future engineers and innovators, my topic is MSME opportunities in the EV ecosystem. By the end of this session, you should feel confident that you can start a business, you can monetize your project ideas, and you can contribute to India's EV revolution. So this is what I will be covering in this. And you see this India's EV landscape, it's a massive opportunity. India is undergoing one of the biggest industrial transitions in modern history. The shift from internal combustion engines to the electric mobility, this shift is creating thousands of new business opportunities. The government aims for 30% of new vehicles sales to be electric by 2030. To achieve this, India needs new battery market makers, charging solutions, power electronics, lightweight materials, and service providers. This is not just an industry, it is a movement, and MSME will play the largest role in the growth. Where do MSME fit in the EV industries? People often think that EV are only about batteries and motors, but the truth is EV ecosystem is huge and MSME supply almost 70% of the components needed by OEM. Every EV requires electronic charger, casing connectors, wiring harnesses, cooling systems, IoT modules, and dozens of custom parts. This is where MSME like uh, you will come in because you have the opportunity to join this industry in a different way. You can start with a small thing. You can start manufacturing a small component or any integral part of the system, and you can start with your business. Of course, we'll be taking in detail further. So let us just see that what about the MSME? No, this MSME, if we can just describe this, the MSME sector of India is of over 6 crores MSME units we have, and they contribute nearly 30% of our GDP, 50% of our exports, and provides jobs to more than 11 crore people. So when we talk about entrepreneurships, we are really talking about building the future of India. How about this? How to start with the MSME and what are the MSME really stands for? What are the classifications of perhaps many of you might be knowing it, but just for the sake of understanding, the MSME starts with the registration of Udyam Aadhaar card. Like we have Udyam registration, we call it now. Earlier we used to call it Udyam Aadhaar. And it's just like that, any individual is having Aadhaar card. Same is the case with the Udyam registration, and it gives all about the pertaining to that industry. All the informations are there. That who is the proprietor or what kind of activities will be done in this particular company. So those all the things informations are there in that Udyam registration. And for understanding this MSME, we know that MSME has got three different sets. I mean, this micro micro is having limitations up to that when we have investment up to 2.5 crore and turnover up to 10 crore. we call it micro industry. If investment is 25 crore and turnover 100 crore, it is called small. And if it is 125 crore and turnover is 500 crore, then it is called medium industry. So why an engineering student should consider himself to be an entrepreneur? Uh, the reason is the engineering students often think I need a job first. That is the mindset we are having. So we need to change this mindset. But engineering is actually the strongest foundation for entrepreneurship. You understand technologies, you understand problem solving, and the EV sector needs exactly these skills. If you start early, even with small projects, you can build powerful companies over the next 5 to 10 years. How to start a business? If slightly, I'll just give you an idea of step by step roadmap how you can start your business. Starting a business is not complicated if you follow a systematic roadmap. First step is identify a problem. The problem, because that is the initial first thing when you think of any business, the first thing you should understand that business is all about the solving of the problem. So if you want to be successful in the business, you should first of all identify what problem, what need you are going to solve if you start this business. Then validate your idea, that whatever idea you have, that validation of that idea should be there. After that, develop a minimum viable product, because initially you make some kind of model or something, so that you can just whatever the idea you have, because you could directly you cannot go for mass production and all. So what you will do, you will develop some prototype of this, and you will test it for real users, and think about that it can be monetized and scale in the future time. These steps work whether you are developing a charger, battery management system, or a simple automatic device. Now, when we talk about what are the different forms of business we have in India, because there are different, management system or ownership of the system, you can call it. So that way, if we can describe this, that before starting, we must choose the right business structure. The first we have the sole proprietorship. This is the simplest form of business to start with, because in which the single person starts the business. It's best for one person startups. If you want to start some business alone, so these are having minimum documentation and minimum those kind of problems, like we take so many registrations and all. So for that purpose, when we started a small business, we started with the sole proprietorship. It is the simplest form. And if it is if we go to the next level, then it is partnership, or we are having co-founder, some of the friends, some of the person, those who are having that knowledge, they can join together and they can start their business in a partnership, making a partnership firm. Then we have LLP, is also now, it is very popular nowadays, because limited liability. It is very simple. It enjoys some of the facilities of private limited company, but with the limited liabilities. So the responsibility of the promoters is limited to certain amount only. Risk is being minimized in that case. Then we have this private limited company, in that we have, it is best for tech startups, those who are seeking investments and choosing the right structure that saves and protects your assets and builds professional credibility. So for that matter, because when you start any business, you would definitely need some funds also to start your business, to buy machines and different things. So for that purpose, when we start a business with the private limited company, it is easier to get the loans from different government schemes. Now, when we talk that there are 4 stages of idea validation, as we already told you about the validation is need to be done. So every business idea must pass 4 validations. These 4 validations are of different types. Like first, as I told you, that problem validation is the problem real and painful. So first of all, you need to understand that whatever business you are starting, whether this business uh, will be able to solve the real problem of and painful areas of different customers for whom you are making this product. So that you should understand first. Then the customer validation, this is the next, that whatever you are producing, whether you will be able to sell it or not, because you may manufacture anything, but definitely if you are manufacturing something, somebody should be there who can pay for whatever you have created, whatever you have manufactured. So that also you need to validate. And then solution validation, that can your product solve the problem reliably. Like Sir HK Agarwal sir was discussing about this, that this need to be according to the requirement of he was saying that the buses and other electrical vehicles running in China, where the roads conditions are good, and this uh, many other specifications, because different countries, different places need different type of specification. So you need to have that, those kind of specifications, because whatever we need according to our need, that the product should be validated, it should be framed. Then we have financial validation, whether the product you are manufacturing, will it be profitable? Will you be able to get some revenue out of it when you manufacture this? And this the record shows, because different from different sources, that the 99% of startup failed because they skip these steps. Do not build something no one needs. So you need to understand this also, because whenever we manufacture anything, we need to understand that whatever we are manufacturing, this product will be validated on the 4 different scales. And those scales, as I told you, that it will be able to solve the problem, and the customer should be ready to pay for this. And this reliability of the product should be there. And then the financial validity, because whatever the business we do, ultimate aim of the business is to generate revenue, to get some profits. So definitely those things you need to see before you start any business. If we talk about the electrical vehicles business model canvas, so what are the different opportunities you can have if you go for this industry, EV industry? So EV industry will have, if you want to convert your idea into a real business model, uh, use the business model canvas first. Identify your value propositions, customer segment, what kind of customers you are going to feed, then revenue sources, key activities, what key activities you will have in that business, then cost structure, and the partnership or whatever category, as I told you before, uh, under which category you want to set up the business. And this is, you can say that this is your GPS who will it will guide you that how to proceed with. Without a business model, you cannot convert technology into a company. And then of course we have to have the project mindset, because project mindset should be such that the engineering students often build projects only for passing marks, as I told you before, but industry expects you to build for monetizations, meaning your project should solve a real problem and someone should be willing to pay for it, whether it is battery cooling system, a smart charger, or a vehicle monitoring IoT board. Ask yourself, how will this generate revenue? So these you need to consider before proceeding for any manufacturing business. EV product opportunities for MSME, of course, we have a specific MSME opportunities we talk about, because uh, we always have some ancillary requirements. The big companies, they would depend upon the small companies, small suppliers, vendors for different ideas, because one big product needs, as sir has also told, about 100 or so different components, and these need to be procured, because everything cannot be manufactured by a single person. We need to get these things from the market, and small setups are made for making the particular parts of a big product. So for that matter, if you just see that, we will have different opportunities, like if we can say that in charging itself, when we talk about the charging, so charging is a gold mine. AC chargers, DC fast chargers, portable chargers, charging management software, and maintenance services. So this itself, the charging itself will have a big, industry. Like earlier, I remember in 1990, when I started with this, I thought that what should I start manufacturing. So at that time, the stabilizers were the fastest growing, and the market requirement was more. The stabilizers were being made for different phrase, then TV, and those because of the voltage fluctuations. So there used to be so many problems. So for that matter, the stabilizers were having very good market. So that way you should, it's a very small thing, a stabilizer, but it was having a very good market, and we could start with that business, and we could take it up to the different levels. So for that matter, you can choose a small kind of things, like as I told you, you can start with the AC charger, or you can start something of that nature, and then you can take it to the very higher level. EV battery industry is a very big market is going to come, and this will have the battery tech as the heart of the EV revolution. MSME opportunities include the battery pack assembly, BMS designing, cooling plates, enclosures, battery testing services, and recycling. Even if you cannot manufacture cells, you can build entire business around packs and services. So this is a very big opportunity for in battery itself, because you will need so many things for this, because we are having different sir was saying that instead of lithium battery, we can have the conventional batteries, whatever we have. So that itself is having very big market. We are having power electronics also, high value segment. Your this one EV needs inverters, converters, induction motors, as sir said, because it's a complete product might be bigger, but the parts used in that, different wires are used in that, connectors are used in that. So those are the things can be thought of. We can start with the manufacturing of those items. Converters, controllers, battery chargers. These require knowledge of PCB design, thermal management, embedded systems, and power devices. High technology means high profit margins. Then we have in this, of course, you can also say that lightweight material and fabrication business is also will also grow, because we need to have the lightweight for higher ranges, and this creates demand for composite materials, aluminum alloys, plastic molds, and precision fabrications. Students from mechanical and electrical department can easily start such business at MSME scales. So that also you can think of, because weight, metallurgy, or the if the weight of the body structure of the EV vehicle is more, then definitely you will need more power, and there will be a lot of energy wastages. So that needs to be some lightweight needs body need to be created. So for that matter, you can think of this, and you can go. You have the opportunity to enter in that line also. And then we have the automation and IoTs also will require for this EVs. We need automation. Is the you can just say that automation is a just hidden hero of EV innovations. We need lot many. We require so many sensors for that purpose. Then telematics will be required. Then dashboard display will be needed, and over and above that predictive maintenance, because if you are going for some drive, or for that matter, if you are not aware of that, how much you can proceed and how you can predict the maintenance, so it will be difficult for you. So for all that matter, you need to have so many sensors, and then that kind of electronic attachment by which you can understand that where you will need some part to be replaced, or it need to be maintained, and those all the things can be understood nicely. All required embedded systems, if you develop a good IoT product, OEM and fleet operators will buy your electrical vehicle immediately. Now we talk about this how you can convert your project into a startup, because since you are studying, and your whatever you do, it starts with the project, and that when you start any project, the what should be in your mind, so that you can focus on and you can build the roadmap for that. So if you want to start with this, how you can convert a project into a startup. The most successful startup begins as college projects. How do you convert your project? Just first of all, as we discussed before also, we pick up a real problem, that what is the problem at large, so that we can encash. If we provide the solution, we can generate revenue from this, and then we build up the prototype. After identifying the real problem, we make a prototype, find 10 real users, because whatever you make, this need to be tested before we go for some mass production of anything. So it's always better that the product which you have developed, and what is there in your mind, that what kind of problem it will be solving, so that the user of that product need to be contacted, and that whatever prototype you have made, you should give it to them, so that they use it, and they give you the feedback. So you collect your feedback from there, and in case there is any problem, and the malfunctioning is there, or your user needs some improvement, so you improve that. And then when it is finalized, and you have tested on all the ways, and you are convinced that the product which you have made, it will be having some commercial value. So now you start with your company, and start the mass production of this, and monetize this. And key is the consistency, because when you develop something, there are different stages, no? And sometimes you may think that it is not working, but in later stage you will see that slowly that it will take a proper shape, and you will be able to achieve your target. Then when we are our government is serious about the development of the EVs, so definitely we are having various supports from the government side. Government I mean, our government has multiple funding mechanisms, and they have the government grants, you have incubators, SIDB loans, we have venture capitals, we can have startup India seed funds, we can have. And if your idea is strong and validated, funding is not a barrier, because there are so many people, those who are interested to start with their business, but they are not having any idea how they can proceed with. They have the money, we find the lot many such investors, those who have money, but they don't have the idea that where to invest that money and how they can start their business. When we talk about the government schemes, just to count a few, we can just say that the government schemes for EV and MSMEs are PLI. This is one kind of fund you can get. And then you have FAME2, state EV policies are there. And then we have MSME support schemes, that offers subsidies. Then we have tax benefits also, because when you start any business, just to support, the government gives some tax holidays also. And there are some areas, where the government have for promoting the business in that particular area, they come up with some tax holidays, like they were having in Himachal, then they were having in Assam. So different times government comes up with the different schemes to boost the particular region or the particular product. Because as you know that nowadays we are mainly we are discussing about the sustainability, because sustainability, as you know, that the environment is the main concern about the sustainability. So obviously, because just to save our environment, the government they go for this EV. They want to promote, because automobiles is one of the major source of pollution. So for that matter, their electrical vehicles are being promoted, and different schemes is being launched by our governments. Uh, so the skill sets required for EV entrepreneurship, because the technical people, those who have already discussed or told you about this, is more because to succeed in this business, you need to then this business, or so to say, any kind of business, the initial knowledge you should have. You should have that skill, that what you want to start, or what the knowledge you have about that. So we are having this embedded systems, thermal management you should know, battery technology you should know, or CAD designing, for that matter, the PCB designing, data analytics, and automation. You can, if you have the knowledge of this, you can start with this business. Are we going well? Hello?
So, yes, sir.
Okay, no problem. Sorry, ma'am. I was just lost in myself. So I just, because just sitting in front of a laptop, no, sometimes we forget whom we are talking about. So we are there, no, still. We are. Yeah, are you able to get what I am saying? Is it relevant, or does it have any, I mean, interest for you?
Yes, sir, we can understand.
Yeah, thank you very much. So, what is the real word? The MSME success stories, if we can say this. So, you all know that EV startups like Ether, Ola Electrical, and Yulo started small, but behind each of them are hundreds of MSMEs supplying parts. This is a proof that students can build scalable businesses. So, because there are still, because when I also know that from the local this GL Bajaj, and then Sarda University students, they built so many such projects, or so many such things which took a I mean, they just started with a very small scale, and it took a very nice shape later on. So that way, because if you can concentrate upon, and if you can choose a product, and get a deep knowledge about it, and then you start and uh, enter into the business, so definitely there are more chances for you to get succeed in that. So what could be, as an engineer, what could be your career path in this? So you will first during your during your studies itself, as a student, you can first start, you will be engineer, then you will be innovator, then you will be entrepreneur. Your degree is just not a destination, no, because it is just to gain some knowledge. But definitely, you, if you want to, if you are looking for becoming an entrepreneur, then definitely this is one part, very important part. But definitely, to start your own business, you need to know many more things. You need to know taxes, and you need to know government policies. You need to know so many other things, because if you are serving somewhere, then you are looking at one aspect, whatever the responsibility is given to you in that organization. But when you become entrepreneur, then definitely you need to have know the many things more about the business. So from college project to marketable product, if we can say that, uh, even a small, simple academic project can be turned into a practical solution. Uh, Add users testing, add reliability, add manufacturing feasibility. You have a business model. And then my final message would be smart. Start with the small things. Think of solving a problem, validate it, build it, scale it, convert your academic knowledge to practical to become a successful person and entrepreneur. Learn more to earn more, dream big, take care of your health, because healthy brain lives in healthy body. Thank you. If you have any question, you can just proceed. This is what I could contribute from my side. So thank you.
Thank you so much, sir, for delivering such an enlightening and inspiring lecture. Your talk on MSME and its growing role in the EV sector has opened our eyes to a world of possibilities. The way you explain contribution of MSMEs covering almost 30% of India's GDP and contributing to a 45% growth rate was truly motivating. Your detailed insights on supplier ecosystem development, localized manufacturing, classification, and registration of MSME, and how these elements shaped the EV revolution were extremely valuable. For us as engineering students, your message encouraging us to consider entrepreneurship will stay with us. Now we would like to call Director Sir.
Thank you, sir. We have successfully completed the first half of our knowledge pack day. It is now time for the lunch break. Lunch will be served from 12:10 to 12:15 hours. We request everyone to be back in the hall promptly by 12:50 for the post-lunch session. Students are advised to make a proper line and leave the auditorium in a proper manner. First of all, the girl side will move. The girls may leave the auditorium and then the boys join their line. One by one, all the rows will leave. Please do not make any noise.